Conversions to slope-intercept form, with and without a graphing calculator. The new thing here would be the with a graphing calculator, because we're going to use a new method. We've seen the with and without a graphing calculator before. Here we're just going to focus on something new. Linear forms. Why do I talk about linear forms? Because the slope-intercept form is a linear form. What are those forms? Slope-intercept form, point-slope form, standard form, and intercepts form. The one that's used most often is the slope-intercept form. This is why I'm going to talk about conversions from the other forms to this one. But we can also use the same method to convert any form to any other form. Let's talk about those forms a little bit, just to see the characteristics of each one of those. Starting with the slope-intercept form, it looks like that: y equals mx plus b, where m is the slope and b is the y-intercept. This is unique, meaning each line has only one slope-intercept form. That's because there's only one slope and only one y-intercept. So this is unique, and that's a good feature for it. Point-slope form. The point-slope form looks like that: y minus u equals mx minus v. What is that m? That's the slope. What is that u and v? That's a point, the coordinates of a point, and this line goes through that point. You understand? Because there are so many points that the line goes through, infinite number of points. There's an infinite number of point slope forms for each line. So this is not unique. Standard form looks like that: capital A x plus capital B y equals c. This form is not unique either, and those capital A, B, C's, they don't have a visual representation on the graph. That's why this is the worst. If you want to graph, you have to convert it. Intercepts form. The intercept form looks like that: x over a plus y over b equals 1. What are those a, b? We've seen the lowercase b, that's the y-intercept, and the lowercase a, that's going to be the x-intercept. So you see there's a reason why this is called the intercept form, because you have both the x-intercept and the y-intercept appearing. This is unique because there is only one x-intercept and one y-intercept for each line, which is a good feature for that form. So those are the forms we want to see how we can start from this form, convert it to the slope-intercept, start from the standard form, convert to the slope-intercept, potentially start from the intercept form, convert it to the start with the intercepts form, convert it to the slope-intercept form. Okay, let's start with an example. The first example is the following: given that, convert it to the slope-intercept form. 2 points here. First of all, two things to emphasize. First of all, they're not going to give you the slope-intercept form. You're supposed to know it. Here I'm writing down to emphasize, but you're supposed to know it, and it's better to know it by heart. Even if you have a formula list that states it on it, you save a lot of time from going back and forth and looking for it. So it's good to know this by heart, and all the forms it's good to know by heart. This one, now what form is this? It's not really important what the name of the given form is, because it can be anything, could be among the 4 known forms, but it could be anything really. It doesn't have to be on any form, and they still ask you to convert it to one or the other. Okay, but in this case, in this example, this is the point slope form. You see that it kind of corresponds. If you write it as, what's the point slope form, is y uh, minus u equals mx minus v. You may say, okay, I see the corresponds, but why is there a difference between plus or minus? Well, this plus 4 can be written minus minus 4, and then you have the exact correspondence. 8 is m, 7 is u, and negative 4 is the u. Okay, so 7 is v and negative 4 is u. Okay, but as I said, this is secondary to know what the name of the given form is. It's good to know, but it's just secondary. We're going to start with the first solution, which is without a graphing calculator, just to remind ourselves how we would solve it. This is the best and the fastest solution, even on the STAAR test, but it involves maybe 2-3 algebraic steps. If you don't trust yourself fully and you want some other method, we're gonna solve it afterwards with the graphing calculator. That's not gonna eliminate the algebraic steps, but it's just gonna be one step instead of maybe 3 steps. Okay, how do we solve this one? There is a method that we've been using in this course. This method starts with doing PEMDAS to the left, then PEMDAS to the right. It's the order of operations, okay? Then we're going to use properties of the equality, the addition and subtraction property to cross the bridge, meaning to move terms from left to right or right to left, and the multiplication and division property of equality to isolate, just leave the y by itself. Okay, and why do we need to isolate anything? Because if we look at the slope-intercept form, y is isolated. Also, there are no parentheses, nothing. It's as simple as possible. All like terms are combined. There's no structure basically here. That's why it's unique. We'll break it down completely. Okay, let's start. Y plus 4 equals to 8x minus 7. I try to do PEMDAS to the left, there is nothing to do. Try to do PEMDAS to the right, and there is something to do. There is a multiplication. There's no parentheses or exponents, but there is a multiplication. And I will do that by distributing. And the next step will be the same left-hand side, and on the right. And on the right is 8 times x, which is 8x, then 8 times negative 7, it's positive 8 times a negative, which is a negative 8 times 7, 56. Okay, am I done with PEMDAS to the right? Is there anything to do? No. So now we'll go to properties of equality. Those are addition, subtraction, multiplication, division. That just means whatever you do to the one side, you got to do to the other side as well. First, we're gonna cross the bridge, meaning move the terms left to right by adding or subtracting. Our purpose is to isolate y, so the plus 4 needs to go. So I'm gonna use the subtraction property of equality to eliminate the plus 4, but to do that I have to subtract 4 from both sides. And well, maybe let's change the color to emphasize what I'm doing. So I'm gonna subtract 4 both sides, and we're going to that 8x minus 56. That's what I got, and now I have negative 4. Okay, y is isolated, so I don't need to divide or do anything else. But if I try to do PEMDAS on this line, I will see that I have addition, subtraction. I have something here. Don't have multiplication or anything. And the next thing that I will do is basically subtract or addition or subtraction. So that's negative 56, negative 4. Also, those are like terms. Those are the only ones that can be added or subtracted. They cannot mix with the 8x. This has an unknown, and I can't say that, oh, it's 8x minus 4 is 8. Another common mistake is at this point, don't say that 8 minus 4 is 4, okay? Alright, so let's combine those. We have y equals 8x. Those cannot be touched. Then negative 56, negative 4 is negative 60, and this is our slope-intercept form. Let's see if I can put it in a nice box. He's not going to do it. Okay. That's the answer without the calculator. So we have to do some steps, not too bad, but now I'm going to do a solution with the graphing calculator. And I'm going to do it for several reasons. First of all, to give an alternative, but also, well, let's see. First of all, to give an alternative solution. Second, to see how, if I need a second way just to confirm. Although how do we confirm now? We put this on our graphing calculator, and we put what's given on our graphing calculator, and those need to have the same graph. If they say have the same graph, then it's correct. Just because you convert a form from one form to another, you're not changing anything. You're getting an equivalent form, so everything is going to be the same, including the graph. So if your answer is correct and you have found an equivalent form, it needs to have the same graph as the graph of the given form. Okay, so this is how we confirm. But there is another reason that I'm going to do it here with a graphing calculator, and that's because even if you know this conversion, and if it's really easy, there's going to be a difficult form, maybe a quadratic, maybe an exponential or whatever, and that same method will apply as well. Okay, so it's just to learn the method. Alright, so here's the solution with a graphing calculator. Let's start by writing down what we got. Y plus 4 equals 8x minus 7. Okay, if we put this on our graphing calculator and we're taking the STAAR test, it's not going to be able to graph it. Our graphing calculator graphs only functions that have the y isolated, like y equals, and it can be anything here as long as the y is isolated. So what I'm going to care about in this method is, in this solution, is not to apply this method with the PEMDAS to the left, PEMDAS to the right, and then all the properties of equality. I just need the y to be by itself. I don't care about what happens here. Okay, and I'm not going to do anything to it to minimize the algebraic steps, but I am going to isolate the y. So the only thing that needs to be done here to isolate the y is this plus 4 needs to go. So how do I get rid of this plus 4? Of course, I'm going to subtract 4. This is the subtraction property of the equality, but that's all I care in this method, this solution. So I'm going to write it as y equals 8x minus 7 minus 4. Again, don't try to do 8 minus 4 is 4. Those are not like terms. The 8 is multiplying a parenthesis. The 4, it does not multiply the same parenthesis. So those are not like terms. They can't be combined. Now, there is a big mess on the right, but I don't care about it in this method. My graphing calculator can do it. Okay, so now let's go and put that on a graphing calculator. Y is isolated, so I can do it. So if I go to the graphing calculator and I put it here, I have the graph. Okay, that's fine. Now what do I do? Well, I want to get the slope-intercept method, and there is a way to do it. I can ask for my graphing calculator to do it, but I have to use the squiggly. Now the squiggly, so let's go back over here. To do this, I can ask for my graphing calculator to do it. So I can I need to know the form. I need to know what the form looks like that I want to do. Y equals mx plus b. Asking the graphing calculator to do it, we write it like that: y1 squiggly mx1 plus b. Now, why do we put the squiggly? Because we're asking the calculator to give its best estimate. Now it's going to be absolutely accurate here because I'm not using data measurements that have errors or unpredictability. It's going to be exact points, so the calculator's best estimate is going to be exactly my form. I give it very accurate points. Okay, but what is those x1 and y1? That's going to have to be a chart that is going to be indicated with x1 and y1, and my graphing calculator is going to read this chart, and then it's going to give me the slope-intercept form. Now the question is, where do I get this chart? Because this chart, I don't know it. I don't have this chart. Well, the slope-intercept form that you're going to get is going to be equivalent with the one given. So the table of the given one is going to be the chart of the that you're gonna feed the graphing calculator. So essentially, this is what I do. I take the given function, I isolate y so that my calculator can find a table. Then I use this table to create a chart with x1, y1. This chart my calculator is going to read, and with the squiggly is going to be able to give me the slope-intercept form. So let's see how that works on the graphing calculator. Alright, we put this function in. Now hitting the wheel and the table, I have the table. Okay. I have 1, 2, 5 points. I don't need 5 points to draw a line, so I'm gonna get rid of 4 of them. Let's keep the simplest one, 0 and 1. And now I'm gonna go to the next tab, hit the plus table, and I will have 0 and negative 60, 1 and negative 52. By the way, 0 with negative 60, that means the y-intercept is negative 60. Remember, to find the y-intercept, you set x equal to 0. So whatever is next to 0, that's the y-intercept. Okay. Alright, but now I have the x1, y1. And now I'm going to ask for my graphing calculator. As long as I know what the form is like, mx plus b. Okay, y equals mx plus b, but I'm going to write it as y1 space squiggly m x 1 space plus b. And if I look down here, I see that m is 8 and b is negative 60. So now I can write it exactly as y, okay, I lost the y now, so let's go back here. Y equals m is gonna be 8, x plus b is just minus 60, because plus minus 60 is minus 60, and that's gonna be the slope intercept. All right. So this is the thing that you need to do on the graphing calculator in order to find that the given y equals 8, x minus 7 in parentheses minus 4, the slope intercept form is y. The corresponding equivalent slope intercept form is y equals 8x minus 60. What did we get in the previous method when we do it by hand? Y equals 8x minus 60. So we're good. So the bottom line was that y equals negative 8x, sorry, not negative 8x minus 60, because once I did that, my graphing calculator told me that m is 8 and b is negative 60. Okay, so here is the method. You see that we only need one algebraic step, as opposed to we did one step here, 2 steps, 3 steps. Which is faster? They're both fast. Okay, which is more algebraic? This one. But this one is a good practice for cases that have a really hard form conversion, and I would have to do a lot of work. Let's give a couple of exercises for you. You can do this one. So given this and maybe this one, okay, that's the exercise. Now let's go to the next conversion, and that's gonna be from the standard form to the slope intercept form. That will be more interesting, I believe. Let's do an example here. You have given 8x minus 3y equals negative 15. Convert it to the slope intercept form, which is y equals mx plus b, and more than likely this is not going to be given to you, so you need to know what the slope intercept form looks like. Okay, let's do the solution without a graphing calculator. How would we start? First of all, we'll look at the slope intercept form. The y is isolated, there's no parentheses, everything is completely broken down. That's what we keep in mind. Let's write what we got. We see that y is isolated, so we use our previous method for isolating any unknown, meaning you do PEMDAS to the left and to the right, then properties of equality, and in particular addition and subtraction to cross the bridge left to right, and multiplication and division to completely isolate the y. We'll look at PEMDAS to the left, there's nothing to do. PEMDAS to the right, there's nothing to do. Let's do properties of equalities to move terms. Since the y is on the left, I'm going to move terms from the left to the right. Which term should I move? The 8x. Can I move the 3? Yes, it's in the next step. And I first do addition and subtraction, that the terms that are added or subtracted, and then I'm gonna do the factors. Here is 3 times. Okay, I'm gonna do the multiplication division afterwards. So what do I do? How do I get rid of the 8x? Negative 8x, both sides. That's going to cancel, and then I have negative 3y equals negative 8x, negative 15. Those cannot be added or subtracted, they are not like terms. Done with crossing the bridge. Now let's fully isolate. So I need to get rid of this negative 3. How do I do that? Let's divide by negative 3. And what else I get? I get y on the left, and they have negative 8x, negative 15 over negative 3 on the right. Okay, I got my first goal was to isolate y. It is isolated. On the other side though, it needs to be 2 terms that are added, and here I have a big fraction. How do I proceed? Okay, I'm going to break this fraction into 2 single fractions, like that. Okay, let's start with let's write y equals, then the orange, this one. First I do the sign, is negative over negative. That's gonna give me an overall positive, which I'm not even gonna write. Then the numbers, 8 over 3. So 8 over 3. And the variable follows next to that smaller fraction. Then I'll do the pink one. Negative over negative is positive. 15 over 3. I know it's 5, otherwise you would have to write it as 15 over 3 and divide by 3 to simplify. Here I know immediately that it is 5, so I don't have to write it first and simplify. 15 over 3 is 5. Let's compare what I got here on the right hand side. I have 2 terms added, and that's what I'm looking for. This is the slope-intercept form. So this is how you would solve it without a graphing calculator. Now let's see how we would solve it with a graphing calculator, and how much algebraic work it saves me from. Okay, because you still have to do work, but it's not gonna be all algebra. It's 8x minus 3y equals negative 15. So let's do the solution here. Oops, the solution with a graphing calculator. By the way, how can you confirm that what you found is correct? Well, it will be tricky because your STAAR testing graphing calculator cannot really graph this one. Okay, so if you're gonna try to confirm it with the graphing calculator, you would not be able to confirm it. So hopefully we got it right at this point, but double check your steps. A way to confirm it though would be to sort of save a couple of algebraic steps, maybe 1 algebraic step or 2 if we use a graphing calculator. and compare the solution. Okay, so we have 8x minus 3y, and that was equal to negative 15. And we need to get the slope-intercept form. To utilize the graphing calculator, we need to have y isolated. To isolate the y, I'm going to start following the method that I know, and I'm going to stop when y is isolated. I'm not going to go all the way. So what is the first step of the method? PEMDAS to the left, there's nothing to do. PEMDAS to the right, there's nothing to do. Then properties of the equality, to move terms from left to right, right to left. I call it cross the bridge. This 8x needs to go. So far, same steps as before. And what I get is negative 3y equals negative 8x negative 15. Okay, no other term to cross the bridge, but now I have to fully isolate by getting rid of this negative 3 that multiplies the y. How do I get rid of it? By dividing by negative 3. So the division property of equality, I'm going to divide both terms. Negative 3 over negative 3 is 1 times y gives me y equals negative 8x negative 15 negative 3. So far so good. I did the exact same steps in the previous method, so I didn't save any work so far. But now I don't care about the right hand side because I have the y isolated. So I'm not going to try to do this part here to break the fraction down into two simpler, smaller fractions. I'm going to leave it like that. Instead, I'm going to go to my graphing calculator and I'm going to get a table. That table is going to give me a chart with x1 and y1. Then I'm going to feed this chart to the calculator by asking it using the squiggly to figure out the slope-intercept form, which is going to give me an m and a b. And then I will put this m and b on my I will plug in the m and b to the y equals mxb, and I will get the form. Okay, so that will be a good practice. Let's see what we got. And what we got is that y equals negative 8x negative 15 divided by negative 3. Let's see if by doing that we'll get the same slope-intercept form. And what is the idea behind the method? The idea is that because the given form, which is a standard form, which is secondary, it doesn't matter what it's called, and the slope-intercept form that I found, they're equivalent. So they have everything the same graph, and the same chart, the same table, everything equivalent. So I'm going to use the table of one to create the chart of the other. Okay, so let's go to our graphing calculator, and let's get rid of everything. Okay, y equals fraction line with the division symbol, and I'm going to put in the numerator negative 8x negative 15, the denominator negative 3. Okay, now it can graph it, it can give me a table. So let's get a table. Now here is a very, very interesting case. We see that the table doesn't have whole numbers, and we're like, oh well, I'm gonna give what I got as x1. I'm gonna give those to my squiggly method, but it's not gonna work. You're not gonna get the right answer. You're gonna get an approximate number. The squiggly method works also approximately, but you don't want the squiggly method to work approximately. You want perfectly accurate results here, because you are dealing with a perfectly accurate given standard form. So what are you gonna do? Well, first notice that those decimals that are not accurate. How do you know they're not accurate? Because they keep going on forever. So we're gonna try to convert those decimals to fractions, and then we're gonna give those fractions to the squiggly method. Let's start with the top one, negative 0.333, and let's say you stop here. If you look at the fraction, that's not good. It doesn't realize that this keeps going forever, so you need to give it enough threes. How many we got here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. If you give the 8 points, it's still not gonna know what to do. So keep giving it threes until it figures out that, oh, that keeps going forever and it's really the negative 1 over 3. Okay, the same thing with the 2.33333333333. Eventually it's gonna figure out that, oh, that's the negative 7 over 3. What about the 7.666667? Well, that is rounded. It's still 66666 going forever. Still going forever. So it's 23 over 3. Okay, so convert those to fractions if you see something like that. Okay, now which points should I choose? Well, I only need 2. So I'm gonna get rid of the sum of them. I'm gonna get rid of that. I'll keep the 0, that goes to 5 for sure. Let's get rid of the negative 1. So I'm gonna keep 0 and negative 2. In general, the best practice is to always keep the 0 and 1. So maybe I should just keep the 0 and 1. But 1 had the 7666667, so I'm gonna keep this one. Let's get rid of that. Okay, let's keep the so those are the only points that I need, keeping in mind that 1 goes with 23 over 3. Alright, next tab, plus sign, create a table. 0 goes with 5 and 1 goes with 23 divided by 5. I got my chart. Let's ask from the graphing calculator to read it. So I just write it as, instead of y equals mx plus b, I write it as y1, so it reads the y1 from the chart, squiggly mx1, so it reads the x1, and then plus b, and that's gonna give me the slope, and it's going to give me the slope intercept. Now the slope is a decimal, so you're gonna convert this decimal to a fraction. Let's do negative 0.4. What would happen if I write it as 0.4? It's still gonna work. Oops. But this is not the proper way of writing math. So I always, and you should always put the 0.4, and that is the slope. So let's see what the slope intercept form is here. If I put everything together, I get that y equals 2 over 5, then x plus 5. And now I think I did something. Did I do something wrong? Let's see. 0 goes to 5, 1 goes to 23. Oh, yes, I did. I put 23 divided by 5. It's 23 divided by 3. Okay, let's see how things change. I still have the y-intercept as 5, but now the slope, let's go here, the slope is 2.6667, so that can be written 2.6666666666, and that is 8 over 3. So let's go to the next tab and put everything together, and I get y equals, the slope was 8 over 3, 8 divided by 3, x plus 5. And of course we see that the top function that I started with is the same as the function that I found here. Alright, and of course I'm gonna compare with the method that I did without graphing calculator and see if I got still y equals 8 over 3x plus 5. If I go here, compare with what I found here, it's again the same, 8 over 3x plus 5. And my form here is first let's write that slope was 8 over 3, b is 5, so I get that y equals 8 over 3x plus 5, and that would be my answer. What did I save now? I saved that step that I have to break this big fraction into two simpler fractions. It's not a lot of work, but if you don't know how to do it and you just know how to move the 8x on the other side, and then you also have to divide by -3. If you only know that but you don't know how to break this fraction, it can be important. Okay. The other important reason why we did that is to demonstrate that there is a method that saves you from the little bit of algebra, that can do part of the conversion for you as long as you can convert it to the y equals, and that method can be applied to other forms as well. Well, let's make up one more example. Let's do the intercepts form and convert it to the slope-intercept form. So let's get this one, x divided by 3 plus y divided by 5 equals to 1. Given this, before I go, here are your exercises. Let me give you two standard forms. -2x, -5y equals 3, and 7x plus 2y equals -5. Given those, convert to the corresponding slope-intercept form. Okay, so obviously this one is gonna get one slope-intercept form and this one another, and you can do it. You should do it both ways, with and without graphing calculator. Okay, let's do one more example. See how quickly we can do this one now that we have a little bit of practice. And I'm gonna start with the statement. Given this, convert it to the slope-intercept form, and I should know that this is y equals mx plus b. Let's do the solution without a graphing calculator. I would start with the given form. I don't really care what the name of it is, because it's given to me anyway. It doesn't matter how it's called, but I do care that I know that the slope-intercept form is y equals mx plus b. But of course this is the intercepts form. I know that this 3 is the x-intercept because it's under x, and this 5 is the y-intercept because it's under y. Okay, how do I convert it? Y needs to be isolated and no parentheses, no structure on the right hand side. First, I locate the y, it's here. This term needs to go and this 5 needs to go. Let's do PEMDAS to the left, nothing to do. Let's do PEMDAS to the right, nothing to do. Let's use properties, addition or subtraction property of equality to cross the bridge, move terms from what side? Since y is to the left, I need to get rid of that, so I'm going to subtract. I'm going to subtract x over 3 from both sides. And what do I get? I get y over 5 equals negative x over 3 plus 1. Okay, then I need to use the multiplication or division property of equality to get rid of this 5. It's divided, so I'm going to multiply times 5. At the same time, I need to multiply the right hand side, the entire right hand side, by 5. So the 5 is going to multiply the entire right hand side, and I put the entire right hand side in a parenthesis. Of course, 5 over 5 is 1 times y. I get the y equals 5. Let's rewrite it. Okay, am I good? Am I done? Well, y is isolated, but the right hand side is not. Two terms has a parenthesis, so it's not good. How do I break this down? Like the same way that I break any parenthesis, I have to do the multiplication. That would be the first step of the PEMDAS that I would have to do to the right hand side, since there's nothing to do in the parentheses. There's no p, there's no exponential. The next thing is m, so I would do times 5. How do I do that? By distributing, and then I will get the same left hand side. Then 5 times negative x over 3 is negative 5 over 3 times x. Then 5 times 1 is plus 5. Okay, and that is the slope-intercept form. Okay, that is without the graphing calculator. Now let's do the solution with a graphing calculator. See how much work we save, and if we get the same answer, and get some practice on that method with a graphing calculator. I'm going to start with the same thing that's given. X over 3 plus y over 5 is equal to 1. the graphing calculator cannot graph that. So y needs to be isolated. So the first step is the same. I don't save any work. I have to subtract negative x over 3. And what do I get? I get y over 5 by itself equals negative x over 3 plus 1. Y is still not isolated, so the same second step as before. I have to multiply times 5, and I also have to multiply the entire right hand side by 5, so I use a parenthesis. 5 over 5 is 1. 1 times y is y equals 5. Let's rewrite it. Now, y is isolated. I stop. I don't need to do anything else. So that is what I give to the graphing calculator. So how much work do I save? I save the last step that I distribute. I don't have to do that step. Okay, I stop here instead of doing one more step. Okay, well, that's something, but it's also good practice. So once I go to the graphing calculator, I'll get a table. I'll use this table to create this chart, and that chart I'm going to give it to the Squiggly method, and after I do that, I'm gonna get a value for M, a value for B, and then I will utilize those values to plug into the mx plus b, and hopefully I will find that as a solution. Alright, let's go to my graphing calculator, and I will have to plug this in, which is 5 and negative x over 3 plus 1. Okay, let's do that. Alright, I have y equals fraction line. I forgot. I'm here, so it's 5 times parenthesis it says first 5 times parenthesis fraction line and negative actually is before the fraction line, so it's negative x over 3, and then I have plus 1. Okay, this is what I start with. Then let's take its table. It has a lot of decimals. Those will have to be converted, and they go forever. Okay, and we have to convert it to a fraction because a fraction shows the accurate value. Let's just keep two of them. One obviously is going to be the 0. The other one is going to be if there is any other good number. Otherwise, I'm just going to take the 1 if no other whole number exists. Let's get rid of that negative 1 too. And then negative 2. Alright. But what is that 3, 3, 3, 3, 3? Let's see. Give it enough 3's. It's the 10 over 3. And now I'm ready to do my chart, which is gonna have 0, 5, and then it's gonna have 1, and not 3, 3, 3, 3, 3.333, but 10 over 3. It's important to give an accurate value, not something that's gonna leave decimals out because you can't fit all the infinite number of decimals in your tab. and not something that you estimate. Alright, now let's ask from the calculator nicely if it can do it. And nicely means with a squiggly. mx 1 plus b. And of course I have another infinite decimal number that I need to convert to an accurate fraction. That's the negative 1.666. Don't stop here. Again, if you stop here, that's not good. Keep going until it really understands that this goes on forever, and that would be the answer. So let's put everything together here. Y equals m is negative 5 over 3. Negative 5 over 3 space x plus 5, because b is 5. Okay, when you see that one line is on top of the other, that means you found the equivalent expression. So hopefully when I compare it with what I have found earlier, it's going to be the same. Let's see, y equals negative 5 over 3x plus 5. And in the previous method, I have found y equals negative 5 over 3x plus 5. So this is correct. The answer was m equals, let's just look at that, negative 5 over 3 and 5. The 5, I expected that it would be 5, okay, because this is the intercepts form and b was equal to 5. I kind of already had this 5. But for the slope, I didn't. And at the same time, there is a way to figure out from the intercepts what the slope is. Here I had the y-intercept was 5, x-intercept was 3. If you do rise over run, what's the run? You go to the left, so the run is negative 3. The rise is 5. So rise over run would be 5 over negative 3. Positive over negative is negative 5 over 3. There was a way to find it directly from the rise over run. But here I managed to have the graphing calculator do some of the work for me. Okay, I think that concludes everything. We got an idea of how to do things a different way, two different ways, with and without calculator. We saw that there's an overlap in the beginning because the y equals part is kind of essential in both methods, so there are similar steps. But we could save a little bit of work, and we were able to make ourselves better, give ourselves some practice on how to use this Squiggly method.